Okay, we have this problem here we want to work. We have f of x is equal to this. First thing we want to do is find f of 4. Now I want to point out with this problem, with all these different parts, there's only one part of this problem that's new, and that's right here, finding the second derivative. Everything else in the problem is something you've done before. For instance, finding the value of the function when x is equal to 4. I just simply substituted 4 in for x, so I'll get 2 times 4 plus 1 over 4 minus 3. 8 plus 1 is 9, divided by 1 is 9. So the value of that function when x is equal to 4 turns out to be 9. So that point, x equal 4, y equal 9, would be on the graph. Okay, next thing, I want to find f prime of 4. So I want to find the first derivative of this function evaluated at x equal 4. So the first thing I have to do is differentiate. So f prime of x, now I look at this and I say I have the quotient of two functions. So I need to use the quotient rule. So it's going to be the denominator, x minus 3, times the derivative of the numerator, 2, minus the numerator, 2x plus 1, times the derivative of the denominator, which is just 1, all divided by the denominator squared. Now I know that because I've memorized that rule. I know how to use that quotient rule, so it's no problem for me when I see a quotient of two functions, I just apply the rule. Then I simplify, evaluate it, do whatever I need to do after that. But if this looks a little difficult for you, then you need to go back to the previous section and review that quotient rule. I'm just going to simplify a little bit here. 2 times x is 2x, minus 2x will be 0. And then I'm going to have 2 times negative 3 is negative 6, minus 1 is negative 7, all divided by x minus 3, quantity squared. So I simplify the numerator, I get negative 7. Now I can say right here, that means that f prime of 4 is going to be negative 7 divided by 4 minus 1 is 3, squared is still 4 minus 3 is 1, squared is still 1, so negative 7 divided by 1, still negative 7. Okay, so now for the new part of this problem, and that is evaluate the second derivative when x is equal to 4. So I have to find that second derivative. So f double prime of x, the second derivative, is the derivative of the first derivative. So here's my first derivative right here, so I'm going to differentiate it. I'm going to use the quotient rule on that too. I don't have to. I can make this x minus 3 to the negative 2 and do it that way. But I think what I'm going to do is just differentiate using the quotient rule. So I have the denominator, x minus 3, squared, times the derivative of the numerator, 0, minus the numerator, negative 7, times the derivative of the denominator. Now, the denominator is x minus 3 squared, so I have to use that chain rule. So I'm going to take that exponent out in front, 2, same base, x minus 3, to a power 1 less, and then I differentiate the base and I get 1. All that is divided by x minus 3 squared, squared again, so x minus 3 to the 4th. Okay, well this is 0, this is positive 7 times 2 is 14, so it looks like I'm going to get 14x minus 3 times 14, I'm just going to leave it like 3 times 14, all divided by x minus 3 to the 4th. And now that I have the second derivative, I can evaluate it when x is equal to 4. So this implies that the second derivative when x is equal to 4 is going to be 14 times 4 minus 14 times 3, all divided by 4 minus 3, which is 1, to the 4th is still 1. Well, what's 4 times 14 minus 3 times 14? 14. So that second derivative when x is equal to 4 turns out to be just 14. Okay, so let's go up now to the slope of the line tangent when x is equal to 2. Just have to know what they're asking for, and what they're asking for is the first derivative evaluated when x is equal to 2. So here's my first derivative right here, so I'm going to substitute x equal 2 into this, So f prime of 2, that's the slope of the line tangent, is going to be equal to negative 7 divided by 2 minus 3 quantity squared. So 2 minus 3 is negative 1. Quantity squared is going to be positive 1. So that turns out to be negative 7. So let me just check my work right here. Negative 7, yep. Yep, okay. Now find x such that f prime of x is equal to 0. So is there a value of x that would make this first derivative 0? So the question is this. Is negative 7 over x minus 3 squared ever equal to 0? And the answer to that question is no, that can never be 0. Because the numerator is negative 7, the only way for a fraction to be 0 is if the numerator is 0 and the denominator is not. So I can never get that negative 7 to be 0, so find x, there is none. So no x satisfies those conditions. Okay, so good problem, really good problem to review. A lot of things that you've done before. Just want to point out again, this part right here is the only new part. And all you really have to know is that the second derivative is the first derivative of the first derivative. So you simply differentiate again. There's no new rules or anything like that. You just have to know that this notation stands for the second derivative. You find the first derivative, differentiate it, and then evaluate it when x is equal to 4. Everything else is review.